you had a great lunch and hope you will be able to see a lot of great presentations. We're starting with 4 great presentations, I'm sure. 1 technical and 3 communication, all on different aspects on how we can support accessibility. We will start with translation, right? So Silvia, Rodríguez, Vázquez from the University of Geneva will begin.
Thank you. Hello everyone. My name is Silvia Rodríguez and I am a PhD student at the University of Salamanca in Spain and the University of Geneva in Switzerland. Tiago has just told me that actually I seem to be a lonely person because I tend to be alone in the papers, so I have to work alone. But actually I am a very social person. Maybe as the presentation advances, I will get the chance to explain why I am always alone in the papers. So today I'm going to present a small part of my doctoral research work, which sought actually to investigate in which ways image accessibility could be assured in multilingual websites. So that means actually in websites that are available in different language versions where content has been translated from one language to the other. And the reason why I chose image accessibility actually has been really well motivated during the last presentations, yesterday's sessions as well. So during the IBM awards session, we had a couple of PhD students that said that actually images are one of the major problems that they are facing in terms of accessibility when accessing content online. And then in the Bachelor Group Accessibility Challenge, Sergio also mentioned that images were among the top 5 elements that still cause a problem in terms of accessibility. So indeed, image inaccessibility is a major cause of frustration, or inaccessibility, I would say, is a major cause of frustration among blind users. And despite the fact that actually the number of missing alt attributes, which is one of the main mechanisms that still is used to implement the text alternatives for images, has been decreasing consistently over the last years. There are studies in the literature that show that. Now actually the problem is not so much the detecting the absence of an alt attribute, but rather the problem now is creating appropriate text alternatives, so and a value for the alt attribute that actually is of high quality. Now, if that seems such a simple thing to do, why we are still having all those image accessibility issues? I believe that there are 3 main reasons. One is that there is still limited guidance for appropriate text alternatives formulation. So there are a bunch of recommendations online about how to compose the alt text. So what type of information to introduce in the alt text depending on the image context, the image purpose. In the HTML5 specification or standard, you have a bunch of examples. There is even an ISO technical specification working on dealing with that topic. But there are rare reference to what is the preferred lexicon to use in alt text, or which are the preferred syntactic structures to use depending on the purpose of the image. Okay, so I don't know, start with a verb or avoid clusters of nouns or a lot of adjectives, etc. The second reason I think is that there is still poor automated support for image accessibility assessment. So most tools detect whether an alt attribute is present or not, but the warnings about the quality of the alt text itself are really too vague. This might be due to the low level of specificity of the tools. There is poor language support, so mostly existing tools deal with English, but if you would like to check the quality of alt text in Spanish, Portuguese, or any other languages, you wouldn't find any tool worth looking into that. And also in prior work, in prior work you would find tools that look into detecting uninformative alt text, but based on isolated words. They will detect image, spacer, blank, but you wouldn't have tools that look into actually the quality of natural language constructions, such as like full sentences. So in this talk, I wanted to mention that when I'm talking about tools, I am talking about assessment tools, evaluation tools, and not other tools that exist out there to generate automatically alt text. So 10 days ago, actually, I have seen this piece of news online about the prototype that Facebook has launched to create descriptions for images. But as you may see in the image, there is like a forest with blue sky, and the text that is generated says tree, sky, and outdoor. And okay, this is quite a nice description, but it might not be so, I don't know, user-friendly or nice to use for blind users or screen readers which want to get the whole idea of the image. And also, you might be familiar with Google research work, which actually has the capability of producing natural language constructions like full sentences. And sometimes they are okay, but for instance, look at this one. The image shows a road sign, I think, and the text says a refrigerator filled with lots of foods and drinks. So this might not work as well. So the third reason why maybe we still face image accessibility problems is that there is uncertainty as to who should be held accountable for image accessibility. So who should be responsible for creating high quality alt text, like web developers who have a rather technical background, content authors who may have linguistic skills, like more entitled to do that, webmasters who are changing content all the time, or which brings me nicely to the topic of my work, maybe in the case of multilingual websites, also translators should look into that as well. Yeah, so let me show you, before I present you my study, let me show you an example of how a website is rendered multilingual. So since the theme of the conference is like education on the web for all, I have chosen an example of one of my universities, the University of Salamanca's website. So as you can see, it's like, this is a screenshot of the website. It's a website like with a lot of images. Mainly all the content is accessible through images. These are functional images with links, so the user would click in an image and get information about the undergraduate programs that are available, graduate programs, and how to get enrolled in the university, etc. And here at the top you see that actually it's also the content is available also in English and in Portuguese. Salamanca is very close to Portugal, and we get a lot of students from Portugal. So when we click on the English website, we see interesting things. So indeed, there was content that was translated. So we had an image that said "Estudia en la USAL," and then it says in the English "Study at the USAL." But other things have changed. Images have changed. We now see like portraits of international students, maybe to attract foreign students to come to the university. The structure of the website has also changed. Some images are bigger than in the original website. So this whole process of taking a source web page and creating a target web page in a different language and for a different target audience is called localization. And so localizers, as myself, need to deal not only with text but also to implement changes in the website at a visual and a functional level. So that means that we have to think about culture, language, but also technical issues. So in the case of images, we will have to, like functional images, for instance, with a link, we will have to adapt the link so that the user is correctly taken to the information in the proper language. If the images are changed, we will need also to change the path, and of course we will need to translate the alt text. But as you can see here, and this is actually a real example, sometimes the alt text is left untranslated, and this can cause also accessibility problems. So the screen reader will pronounce in a funny English accent the text in Spanish, for instance, in this case. So yes, in last year's conference in Web4A, I presented the preliminary results of a study that I conducted with localizers. And actually I showed that this was not an isolated case, the case with the University of Salamanca, that actually the existence of text alternatives is often neglected by translators. And I also talk about, and I also presented that the use of accessibility-oriented quality assurance tools, I will show you which ones, actually contributes to increase the alt text visibility. So it increases awareness among the translators community about the existence of this alt text. I hypothesized as well that these tools could potentially boost the alt text quality simply by the fact that translated alt text will be more accessible than a non-translated alt text. But by that time, I didn't look into detail into the quality in terms of relevance of the images concerning of the alt text, concerning the purpose of the image. And this is precisely what I want to present today. All this introduction to go into details. So I want to focus on the impact that the use of such tools. I think you will use the bell. Have the impact of that these tools have on the quality of the alt text that localizers produce. So a little bit of a background. This study, we conducted a study consisting of two stages. The first one was a web localization experiment for which we recruited 28 localizers, and we asked them to perform two tasks. The first one was to localize a website containing 130 images from English into French without the assistance of any tool. And then we asked them to perform a quality assurance task using two different tools. So for each one of the translation, for each one of the tasks, they will get different translation versions. So translation 1, 2, and 3. So these two tools were A Designer. A Designer is a disability simulator tool that also serves as an accessibility evaluation tool. And we chose this one. One of the reviewers asked me to motivate more why I have chosen A Designer. It's because currently, today, or as far as my knowledge is concerned, is the one that gives more feedback about the quality of alt text, and could be comparable to the second one that we use, which is Acrolinks, which is a language validation tool that relies on morphological disambiguator and a part of a speech tagger, so which is basically NLP software, natural language processing software. And we customize it for accessibility purposes, and we presented in the last Mueller Group Accessibility Challenge. There is a video out there that you can check on papers if you are interested on the work we've done on Acrolinks. So then what did we do? We took all the output of this experiment and we asked 7 blind users to annotate the alt text produced by the localizers according to a 4-level scale. So from 1, that not appropriate, to 4 very pertinent. So 2 would be acceptable, 3 pertinent, and 4 very pertinent. I will skip that part. So there is more details in the paper about the experiment, like the evaluation setup and the methodology. So why we wanted to do that is to test 4 very simple hypotheses. First, we thought that the use of tools could lead to more appropriate text alternatives in the target website. We also thought that only when one tool was used, Acrolinks would lead to better results than A Designer. When that 2 different tools were better than 1, and 4, that when 2 tools were used, that Acrolinks would perform better anyway, regardless of the tools used. So just the overall results. This graph shows the score distribution across the different translation versions. In T2 we have two different versions according to the different tools used, Acrolinks or A-Designer, and we can see that there was a considerable decrease of non-appropriate text alternatives here when Acrolinks was used, but almost no difference can be seen when we compare T1 to T2 when A-Designer was used. And then also an interesting remark is that when both tools were used, similar results were obtained when compared to Acrolinks. And to know whether these differences were significant, we performed a statistical analysis, and one way measured ANOVA and Torstock analysis with Taki tests, and we found that all the difference across the different pairs of translation versions were significant. So we could support our two first hypotheses. Now if we look, so there was one regarding the order, one hypothesis regarding the order. If we divide the data from T3 into, according to the tool used during this translation version, we will get, I would like you to focus on this part of the slide. So we would see actually that there are differences between the amount of non-appropriate text alternatives achieved when Acrolinks was used last, when compared to when A-Designer was used as the second tool. So what all this means? And the differences between the different translation versions were also significant. So in general, we can see that tools are useful. So what does this mean? So I am running out of time. Actually, all this means that if equipped with the appropriate tools, translators or web localizers can really contribute to image accessibility of multilingual websites, and not only by achieving high quality or an acceptable alt text of an acceptable quality, but also they may able potentially to spot problems in the source text and point it to the client or to the web developer. And also by looking at the results from Acrolinks, we could say also that NLP-based solutions could cover the limitations that actually we are currently seeing in web accessibility evaluation tools regarding the alt text assessment. Now, as future work, we would like to see whether the good performance of Acrolinks that we have observed is maintained when the tool is used by other web professionals, because Acrolinks is at the end a language-based or language-oriented tool, so probably translators were more at ease when using this tool when compared to A-Designer, which is more technical oriented. And also we would like to see or to explore other language pairs, because we work only with English into French, so maybe working in different language pairs would lead to different results. So thank you. If you have any questions, I'd be happy to answer.
The chief executive.
Okay.
So we still have time for some questions, a couple of questions. Anyone? I have at least one.
Okay.
From what I read in the paper, your evaluation at least didn't consider the whole context of the page, right?
Yes.
So you were just assessing the quality of the alt text, presenting the image to the evaluators, right?
Yeah.
How will an image inside the context of a page which has more content could change these results?
Yeah, so this is actually one of the limitations of our study, definitely. After the translation experiment, we gathered more than 10,000 text alternatives, and we wanted all of them to be assessed. So we considered the option of really giving every website to the users, or even think about a different methodology, but actually it was a really high amount of text alternatives to assess, so we tried to increase the ecological validity, at least, of of the study by providing users with a detailed description of the context in which the image was. So I skipped this slide, but from the almost 2,200 alt texts that were assessed, for each image, so this was done in online, in a survey online. So for each image, we would tell the evaluators where the image was placed according to some instructions that we gave them, so they could do the evaluation and have the instructions next to them. And then we would just add a contextual description describing the image itself, and if it was a functional image, what action will be triggered when the image was clicked on or clicked upon. But yeah, maybe we would get different results if we select just a small data subset from this whole set and we present it in the real context. Yeah.
Well, I of course haven't read the paper, but it seems from your presentation that you have just studied the alt attribute. Have you taken into account the fact that the web is moving to different patterns, like there is another figure element, so instead of the alt attribute, the caption might be in the fig caption element.
Yeah.
So have you taken this into account in the study?
Yeah, so we focus on the alt attribute only because after like a comprehensive literature review, we found out that actually is the more robust mechanism that is used today. But we are aware that other mechanisms exist, like the fig caption, etc. It's definitely something that we would need to look into. But as far as I am concerned, the best practice is to write a fig caption differ from the alt text, actually, because the fig caption can be used in conjunction with together with the alt text. So yeah, that would need further research, I think. Yeah.
Yeah. Well, the fig caption can provide anyway the description that the alt attribute provides. So in a way, the image might be accessible in the sense that you've got the description fig caption. So the result might vary based on that.
Yeah. Yeah.
I mean, the purpose of the whole study is to make images accessible.
Yeah.
Detected
Yeah, definitely. Yeah, yeah.
So the fig caption might provide that alternate effect.
Yeah, sure. Yeah, and not only alt text. Within the context of multilingual websites, we could even look at like localizers modify not only alt text but titles, summary elements, fig caption. Like we could even look into other aspects or elements of the web page. Yeah, definitely. Thank you.
I'm curious if your translators are actually editing pages or if they're editing content that's within a database.
Yeah.
So it's like, here's the English string, here's the...
No, so they were given HTML documents. So normally, ideally, the localizer should be entitled to also modify HTML files or CSS or to have more of a context, because it's true that we also get sometimes Excel files with a list of strings to translate out of context, and this is even more difficult than just for us to go into the HTML. But it's true that we are not computer science, and so we have been trained to just carefully look at the code, not mess up with things, and to know which things we need to change and which things we don't. But the whole point of my study actually is just to increase awareness about accessibility among translators and localizers, because we can improve the quality or the accessibility of a website, but we can also mess it up. And if it was accessible in the original source web page, we might do things wrong and then deliver a target website that is completely non-accessible. So, yeah.
Thank you.
Thank you.
Okay, so the next presentation, supporting accessibility and now the accessibility of training platforms for people with disabilities. Andrea Britto from IBM Research Brazil will do the presentation.
Okay, thank you. So I believe you know me by now, right? I was here yesterday to demonstrate this platform to support personalized training for people with disabilities. Today I have a communication paper to present on the same topic. Those works were developed together with two friends from IBM, Cardonha and Rodrigo Guimares. And yesterday I have demonstrated the features and functionalities of the platform, so I believe that today it would be more interesting to talk about our motivation and experiments, otherwise it could be a little boring, right? So this is our motivation. We are living in the MOOCs era right now, which promote the idea of learning anytime and anywhere, but most of them are not really focusing on the everyone part, right? Most of these famous MOOCs are not tailored for people with disabilities, are not supporting personalization features. So on the one hand, MOOCs have solved the problem of massive content delivery, and now we are trying to investigate, on the other hand, how we can scale personalization as well. So this project has been partially funded by the Brazilian government. The work that Wagner presented yesterday, it was the first technical presentation, is also part of this FINEP project. And Wagner have already told you guys that we have this partnership with a PAI de São Paulo, which is a non-governmental organization that deals with people with intellectual disabilities. So we have been interacting with them for a while now. We have made some observations before implementing our platform and also after implementing the educational platform. And the first experiment that we made with them was published last year at Assets. It was an experiment to evaluate how students with intellectual disabilities interact with a traditional MOOC that was not tailored for them. We used Khan Academy in a vocational training session, so we were not dealing with kids, right? It was adults with intellectual disabilities. And on the one hand, there was lots of problems regarding the interface, which was too complex and confusing for them. But on the other hand, we saw that using tablets was actually really, really cool in this environment because of two things. So first, there's this aspect that we need to take into account. So we're dealing with low-income communities, and some of these people had never interacted with a tablet before. So first, they were pretty excited to be using the tablets, and second, they actually interacted pretty well with it, even the ones who had never had access to a tablet before. So this is why we decided to incorporate tangibles in our project. So we have this web-based course for instructors to create courses, and then the students will have the mobile application to execute those personalized courses. In terms of architecture, both the web portal and the backend server are developed using Play framework. The mobile application is developed in IBM WorkLife, so we're talking about web-based mobile applications that can run in Android, iPhone, and everything is on the cloud using IBM SoftLayer. And yesterday I have presented to you the overall scheme of the platform. So basically, instructors create step-based courses. The idea of using steps is because we're also focusing in this, vocational training, which are usually very procedural. And in each step, the instructors can define that people with different disabilities would be having access to different media formats, and the platform automatically personalize these contents to the students. It was all made using a tag-based personalization, okay? So instructors assign tags to students. They assign, for the steps, they can assign alternative contents for these tags as well, and the system does all the mapping. So we believe that this was a relatively simple way of, trying to scale personalization. And the courses of our platform, they contain this nonlinear course structure. So being an instructor, I can define that whenever students have to respond a quiz, they can take different paths according to the answers that they provide. So I have actually talked about it yesterday, but I didn't give the motivation on that. So of course, courses created in this way are much more flexible. You can do a lot of cool things. And in this context of intellectual disability, it was interesting because the instructors told us that when teaching people with intellectual disabilities, repetition is very important. So it is really desirable to have those loops in the course, especially when students are not progressing so well. And there are also interesting examples. For instance, in API, we found out that some students with intellectual disabilities have a hard time in solving basic math expressions. But on the other hand, if you show them the same expression, but instead of numbers, you use two objects, they can actually count these objects and give the correct answer. So one of the experiments that we made with the students was we created this course that was composed basically by math expression quizzes, and whenever the students got it wrong, they would be directed to the step saying, well done, etc. And whenever they got it right, we would load this intermediate step representing the same expression using images. As Wagner told yesterday, it's very important for you to use images that are in their context. So we're working with these people that were working in the office, so we were using pens and notebooks, stuff like that. So in the end, the instructors, they could know which students had problems with solving math expressions and which had problems with actually the way that these expressions were presented to them. And the platform allows the instructors to know this because we are providing this real-time progress log in which they can see the time spent on each steps and the answers provided to each quiz for each individual student. And I didn't talk about it in the Lightning presentation yesterday, but our platform also supports 2 execution modes. The students can be executing the courses in a self-paced manner, so they can be, different students can be loading different steps at the same time, but also in a structure-led approach in which the instructor would be delivering the steps that they should see. This was because of the Khan Academy experiments, because as I have mentioned, the students, they were really excited with the tablets, but sometimes they just got overexcited, they just wouldn't pay attention to the instructor. So after we implemented EVA, we made some experiments with students and experiments with instructors. One of the experiments One of the experiments that we made with the students will actually be presented next month at Sky. And we are trying to analyze this balance between self-paced and instructor-led course execution, because there are a lot of questions regarding autonomy and things like that. And in this paper here, we were reporting the results with experiments with instructors. So we have recruited 2 instructors from API. They were placed in separate rooms and they were supposed to analyze the web portal for course creation. And we gave them a list of tasks that they should be doing with the platform. Basically, they were supposed to create a course, add multimedia contents, create nonlinear paths, create alternative contents, use all the functionalities that I have described yesterday. And they could also be using the mobile app to see how the course was being rendered. And in the end, they were able to complete all the tasks, and they really enjoyed the platform. One of the instructors was actually the one who worked with us in the Khan Academy experiment, and he said that the interface was much more clear than the one from Khan Academy, and they had really appreciated the main features that we have decided to use in a platform. So for the nonlinear structure, they could see those 2 examples that I said regarding the presentation modes and the repetition part. For the tags, it was interesting because right now we know that our system is very limited in this terms of tags because we're just considering visual, audio, and hearing impairments. But actually, an example that one of the instructors gave was to use, for instance, specific tags for people with Down syndrome, because for these kind of people, using larger images are preferable. And in terms of log, they thought that it was very useful, and they also gave this interesting example that sometimes these students, they have to consume this explanation and then do a quiz, but sometimes they just go really fast on the explanation, and that's the reason why they miss the quiz. And the log could show that actually these students, they respond incorrectly due to laziness or anxiety rather than because of a limitation, cognitive limitation, right? So right now we're thinking about how we could compute automatic algorithms using the log data information and find partners working with other types of disabilities as well. So that's it. Thank you.
Thank you, Andrea. Questions? We have time for questions.
Also, I was right in time.
Okay, I'll start. This is great, I would say, for the student, but let me place in the shoes of the instructor.
Okay.
Now you're giving me tools to create a lot of content, right? So aren't you concerned that you might be overloading the instructor?
Actually, we were just trying to make it as easy as possible for the instructors. For instance, in API, there's this whole social economic restrictions, and for them, the way it is kind of complicated because all the instructors should create their courses, and we actually believe that with a platform, they could be using, a single content for them all to be applying at their learning sessions, and we believe that it would be, actually we don't believe, they told us that it's much easier for you to use, electronic platforms to access how the students are performing. So yes, the content creation is a problem. It's not the problem that we are trying to address with this platform. It's not a platform to create content, but to create courses, right? But so this was not really the focus. But anyway, I don't think that the platform is bringing an additional challenge, in my personal perception.
Thank you very much for your presentation. I have a question. There is an international effort that is putting together, well, there's a standard called Access for All, which is for learners to create a preference file that declares how they prefer to learn. And then there's a community that's contributing various ways of discovering that and then making that a portable preference file. Are you linked into that, or do you have plans to allow this personalization effort to also respond to that? There's several projects like the Lumina project, the Preferences for Global Access, the Adaptiva, the Alternativa, and in fact they're also in Portuguese as well as in Spanish. Are you familiar with those? Or?
Yes, in this implementation precisely, I mean, we were trying to do something generic for multiple types of disabilities, but since we're dealing with this group with intellectual impairments, it is kind of natural that we did, some things more that ended up being more tailored for them. So this decision that we took initially of using the instructors to place the tags, in the students, was interesting in that specific scenario, because in API there's this whole economical things where students don't really know what kind of disabilities they have. So in this initial decision we used this approach, but we already thought about it. It would be very interesting that in the future the students could be assigning the tags, picking the tags, using the preferences. So far the interface of the mobile app is not customizable, but it would also be interesting, to use those kind of preferences for additional things. So this is an ongoing work, and right now we know that there are several limitations, but the answer is yes, we are thinking about it in the future.
That's great, because it would add to that
Yes, I
Other
think
systems that
it
you're
would be
hoping to
much
work with.
richer, right?
Yeah, and they would gain that metacognition and learning to learn, and
Yeah.
it would extend the discovery environments as well within that effort.
Yeah, that would be great. Thank you.
Any further questions? I still have none.
Oh.
You touched already on one point because you have information regarding students' abilities. You use it to personalize the content that you're presenting them, but you touched this right now. You don't personalize whole interaction experience in the whole interface, but I see that's something that you're still thinking about. So I won't ask this one. I'll ask another one. Why did you choose to do another e-learning platform? Why didn't you start with one already existing, Moodle, edX, something? And would it be much more difficult to use these personalization mechanisms on existing platforms that instructors and students are already accustomed to instead of having a new platform to learn?
To be quite honest, we decided to do this new platform because we believe that we would have more flexibility in experimenting things. But honestly, we can just, in the end of the project say, well, maybe it would be easier if we could just extend other platforms. So I don't really have this answer right now. But yeah, of course, that's an option. It's because we're also, thinking about things in Portuguese. There are some platforms that are not, supporting the Portuguese language. Of course, for these people, it's the only language that we can work with them. So this is why in this exploratory work we decided to do something that was very tailored for this community that's working with us. Okay.
Thank you.
Okay.
So let's thank our speaker once again. Okay, so our third speaker is Jobke Wentzel from the University of Twente.
Yeah.
And now another different perspective on supporting accessibility. We're going to learn how wearables can contribute to this. This is something really interesting and with a promising future, I believe.
Yeah, there we are. So thank you for the introduction. So my name is Jobke Wentzel, and I will be discussing with you Wearables for All, also on behalf of my colleagues Velleman and Thea from the Geest. So we go from the education a little bit towards the wearables. I think I'm just a year late because apparently that was the theme of the conference of last year, but I hope you will still find it interesting. So in this presentation, it's a logical setup. I will explain what the goal of my project is and tell you what we've done so far, the draft guidelines that we've created. I will get into that. And I will also ask for your help. And maybe we will have time for some discussion if the bell isn't applied before. So, as we've talked about it before, there's many ways in which people with a disability, and in a particular case, people with a visual disability can have assistance in daily life. The cane, guide dog, braille readers, magnifying glasses, all these kind of things. And it can be maybe difficult to carry around that every day throughout your daily tasks, because it's a lot of different assistive devices or technologies or things to use. So what we saw is, of course, we have now also the very nice smart wearable technologies that are becoming broadly available. For example, smart glasses, watches, and whatnot. So we were thinking, what potential do such devices have to take over some, if not all, of the tasks of the traditional assistive devices? So what we thought is, let's focus on wearables that are smart, that they do more than just tracking your activity. For example, they should be able to, at least in the focus of our project, should be able to give you some information. We want to see whether they are accessible, both the applications that run on them, but also the design itself, so the device, for example. And this includes that they should have some sort of multimodal interface, because what may be perceivable for one is not for another. So, and also the way of interacting with the system should be multimodal. And then we were especially interested in the wearables, because, or nearables, you even have ingestibles, although I do not know if it's easy to interact with an ingestible. But a wearable has such a nice potential because we wear them on or near the body, and it could be in a very unobtrusive way. So I do not have to notice all the time that it's there, but it can still give me some information or assistance or support, and I do not have to touch it, use my hands to operate it in the ideal situation. So our project is aiming to create some design guidelines for wearables within the scope that I just mentioned. So we wanted to see, now is the time that a lot of wearables become available. What could we do to help to let people who create them make them in such a way that they would be accessible to the broadest range of users possible? So we look into the literature, what is known already about the development of wearables, maybe case studies, design guidelines. We also wanted to tap into the experience of actual development cases and practice. We want to co-create together with developers a definite set of design guidelines, and I will get into it, what I mean with that. So we've done some work so far, otherwise I wouldn't probably be here, I think. So I've gathered a lot of mostly scientific publication, but also standards and guidelines on wearables, but there were not so many. So also web accessibility, of course, multimodal interfaces, because they're so relevant for at least in our view, for the accessibility. And we also found quite a lot of case studies of some sort of wearable device to support visually impaired persons, persons with a certain disability, etc. And I'm reviewing them at the moment to find out what design guidelines can be extracted from them. And we use a heuristics approach to do that. So for example, I look into how specific they are, if the guidelines that are from this certain publication very exhaustive or not, how they can be interpreted, etc. So that gives us at least some starting point for defining some guidelines. And then I've also been interviewing, 5 minutes, okay. Been interviewing people that had experience, researchers and developers that had experience in developing technology for specific target groups, but also in developing wearable technology. So what they said was, okay, guidelines, they can be very useful, but they are sometimes too specific or too broad. And when we start developing something, we usually just rely on our own knowledge. So you can make it a guideline, but I don't know if we're going to use it. But most people we interviewed, they see a great potential and wonder how will we be able to do, for example, human-centered design, which is probably very important to ensure that it's a good fit with special target groups. So that was something that was mentioned sometimes, that it can be difficult to involve users. Also, accessibility is something that should be considered in early design stages, well, maybe logical, but and they mentioned, well, if you make guidelines, should they focus on the process or the technology? So this is ongoing. We still haven't decided on what would be most useful, but your help will maybe later on help in that. So we also looked into practice. One of the projects that's running in our university is a project to develop applications for smart glasses. We started out with Google Glass, but now we are looking into other options for reasons that are probably logical, because it doesn't work so well. But we are looking to support in and outdoor wayfinding and emotion recognition. And at this moment we are doing the first test for the emotion recognition app with visually impaired persons, where they get haptic feedback. Use now a head-mounted camera, but later on it will be a smart glass. And I'm studying this development process to see what things are happening that maybe should be in the guidelines. So we created some draft, and there's some themes that we definitely want to make sure that are reflected in the final guidelines. That would be ensure that there's a multimodal interface. So input and interaction can be in different ways. If I cannot see, I want to be able to talk to my system or receive audio information or maybe haptic information, for example. Systems should also provide appropriate amount of feedback, not only on what goes wrong, but also on what goes right, and really depending on the context and situation in which it is used. So I want to be able to personalize it or apply my own preferences, or maybe have the system learn based on how and when I'm using it, what my preferences are. Because it's worn, that's something that people tell us, okay, thank you, is we should also pay attention to human factors or wearability. Because I do not want some big, large thing on my head or wherever that makes me conscious of using it all the time. It needs to blend into my activities seamlessly. Also, the socio-ethical impact should be addressed during the development already. So what will happen if I'm using it when there's other people around? Will they accept it? Will they be skeptical? Will they think, what is going on? Why are you maybe making video tapes or something? And it should be adaptable to the situation. I think I already addressed it. So I was very happy that I was able to present this here, because I thought this would be a very good moment to ask you, and you all have some experience with either developing for special target group, disability, accessibility, or maybe also with wearables. And I've created some drafts so far, and I wanted to ask you if you were willing to participate in a Delphi study that I'm setting up at this moment. For you who do not know what it is, I put a picture of the Oracle of Delphi. And Delphi study is a study wherein you want to get consensus with usually experts, but I think experts can be very broad, either by experience, personal experience, or research, or whatever. And I want to send out a draft in multiple rounds, and in each round by email you can get feedback on what others have mentioned in previous rounds. So in that way you get some consensus on the guidelines. So I'm planning this for between April and September. Well, it will be a little bit later than April, I think. But so if you are interested, if you think that you have some opinion or experience that you could share in design guidelines for wearable technology, then I would be very happy to hear from you, so that you can help to give at least some guidance into how we can make wearables more accessible. And I think there might be time for questions.
So, okay, I'll not start this time.
I've got a question about the tactile feedback for emotions.
Yeah.
Tactile typically is more Boolean. It's like on the Apple Watch, if you're making a right turn versus a left turn, the vibrations are different, but you don't have 20 types of vibrations.
Yeah.
So I was kind of curious why tactile was chosen for emotion detection when there could be so many emotions.
Yeah, that's a good question. What we are doing now is we have a haptic belt, and it's been tested in various specific situations, for example in aviation, to give navigation cues or information. So it's a circumplex model, and right now we're testing whether it's sufficient to just give technical information, because it's worn in the middle, or in your, well, on the belly, so to say. In the front it would be positive, in the back it would be negative, and then you have surprise and well, it's 4 axes, and we're testing how many specific support is needed to be able to make a good interpretation of the emotion. So we're testing that right now, and previous research has shown that a belt in itself can be a good way of conveying this information. That's why we chose that. But then, if the system works, we will look into other ways and other maybe if you're talking about a watch, how many information can we convey via a watch? But this is the first setup. So does that answer your question? Any other questions? I just wanted to show you this.
I just wonder how you plan to address the issues with limited functionality of the different wearables, and the fact that there's so many different kinds of wearables, different, from very expensive ones which have lots of facilities to very limited ones. How are you going to try and address those in the design guidelines? Because obviously it might not be technically possible to use up to convey everything.
No. Yeah, that's a really relevant concern that you raise. In the ideal world, we would like to see also the people that make these kind of wearables to think about how they can maybe add a few functionalities to make them much more accessible. But that will probably not, in every case, be, that will not be realistic. So we just strive to see whatever is out there and give guidance on what is the most that you can do with this kind of technology. So but it is a difficult. But it's also it's not only about providing or making guidelines for readily existing wearables, but also creating maybe a little bit awareness. And because a lot of developers we've talked to so far, they say, it would be very nice, but I really do not know where to start. I think they just start making something, and then later on it's nice if it's accessible, but that was not a target goal. So, But it has so much potential, so that's why we wanted to at least provide some help, some starting points. Yeah? Yeah, that is one of the considerations, because it's so hard to find one thing that does it all. So either we will be focusing on, how to create a wearable that is multimodal and can do as much as possible, but also how can you ensure that if this is what the functionality that you want to include, or what can you do to make sure that it's available in different modalities. So and then multiple solutions could be a good idea. On the other hand, you do not want again the situation where somebody has to put like 20 things on or in his body to do everything that they want to do. So there's a trade-off at some point, I would say.
Will you be looking at extensibility? So like for a Pebble watch, you can get an extensible strap.
Yeah.
So you might not have to get the whole thing, but if you want it, you can get it.
Yeah, that would be good. Again, what also would be something to look at is how expensive would it all be, because as with the mobile phones, for example, you could buy a new one every year, but that's usually not the situation that a lot of people with a disability are in. So what is technically possible is not always what is in real life accessible, but these are things that we want to look at least. So yes, but there's a lot of restrictions to take into account. So your help is very, very welcome. So I hope that at least some of you can send me. Yes. Okay. Thank you.
Okay, so I don't think we have time for any more questions. If you want to continue the discussion and do it after this session, we now move to the, let's thank once again the speaker.
Thank you.
And now let's move on to the final presentation of this session. Julia Mueller from Manchester, representing a whole team almost here, right? And this is a really important social service, I would say, that they are providing.
All right, so hi everyone. I'm going to be talking about access to online health education for lung cancer. My name is Julia Mueller, and I'm a PhD candidate from the University of Manchester. And I'm working on a cross-disciplinary project between computer science and psychology. So my background is originally in health psychology. So first of all, some background information on lung cancer and why it's an important topic in health education. So lung cancer is the most common cause of cancer deaths worldwide. And there tend to be delays to the diagnosis. So it's usually diagnosed at a quite late stage when it's very difficult to treat. Now, there are multiple reasons for these delays, but one of the reasons highlighted in previous literature is that people often delay for several months before seeing a doctor once they start having symptoms. So clearly, we need to do something to improve health education about lung cancer and educate the public about warning signs and symptoms. So what does that have to do with accessibility? Well, the definition of accessibility that we're working with in this project is that it encompasses all users in all circumstances and their ability to access information on a given website. So that means we're also looking at users who might have difficulty retrieving and accessing relevant information for any reason. For example, older users who are less tech savvy, users with low socioeconomic status, who have lower education levels and lower health literacy. And this is the case for lung cancer, which means that people with lung cancer are less likely to access health information, which means that it's more difficult for them to recognize symptoms. And that in turn contributes to delays to the diagnosis, which reduces the chances of survival. So as you can see, it's really, really important that we find ways that people with lung cancer can access the right information before the diagnosis. So if we look at this from a very, very basic perspective, people start with some symptoms and they need to seek medical help in order to be diagnosed early. But there's a number of barriers in the way. Some of these relate to healthcare professionals and the healthcare system in general, or to medical factors. These are partly outside of our control and also beyond the scope of this study. There are also factors related to the patient and to awareness and knowledge about symptoms and beliefs and attitudes, and also cognitive biases. And these are amenable to change, which is why we're focusing on them. And the way we decided to target this in this study is that we're using psychological theory and information personalization. And I'll be explaining in the next few slides what we mean by that. So overall, the aim of our project is to find out if we can use the web to encourage early help seeking for lung cancer symptoms, and we want to find out how effective information personalization and theory-based components are. And the way we're doing this is that we created a symptom appraisal tool, and that's online under the link when2go-study.co.uk. So that's live at the moment, and anyone who has any worrying symptoms can use this tool to help them find out if they need to present to a doctor. The way we're recruiting at the moment is mostly via Google AdWords. So our link is displayed whenever people search terms like lung cancer symptoms, persistent cough, or breathlessness, or any other related symptoms. So our tool uses information personalization. The way this works is that the user inputs some information about their symptoms and their risk factors, and the tool then provides detailed information on the specific symptoms and risk factors. And it also outputs a personalized summary, which includes a recommendation of whether medical help should be sought in this specific case. And this is based on UK clinical guidelines. And then we're also using psychological theory. So the theory we're working with is the theory of planned behavior, and this is one of the most prominent theories used in explaining health behavior. And so this theory explains behavior as a function of intention to perform that behavior. And intention in turn is a product of attitudes towards the behavior, perceived social norms, and perceived behavioral control. So the theory postulates that in order to change behavior, we need to target attitudes, perceived norms, and perceived behavioral control. And the way we did this was very simply, actually, it's by introducing very simple components into our tool. Here's an example. We found from the previous literature that people often have the attitude, you shouldn't see a doctor for a cough because it will waste the doctor's time. And we just target that by including a quote by a health professional explaining why it's important to present certain symptoms early on and that it won't waste the doctor's time. And this is a real medical oncologist working in Manchester in a hospital, so this adds to the credibility. So how did we test if this personalization and theory components are effective? So our basic study design is that users enter our homepage and are then randomized to one of 4 experimental conditions. One is our tool, which I just described to you, which is called When to Go. Another condition is a version which includes only the theory-based components but not the personalization. Another condition is it includes the personalization but not the theory-based components. And then the 4th condition is a typical lung cancer website for comparison. Afterwards, participants complete a survey which includes our primary outcome measure, the intention to seek medical help. So, and in this line graph, you can see the comparison between the 4 experimental conditions in their reported intention to seek medical help on a 7-point Likert scale. So what we found was that people who completed our tool with the theory components and the personalization reported significantly higher intention to seek medical help than participants who received only personalized information without the theory-based components. And so these 2 versions of the tool are the exact same, except that our tool includes the theory-based components and the other one doesn't. So since we see a significant difference there, we can tell that the theory-based components must have a causal impact on intention to seek medical help. We did not find a significant difference between our symptom checker tool and the version that includes the theory but not the personalization. So that was at a p-value of 0.2. When comparing our symptom checker tool against a typical lung cancer website, we didn't quite find a significant difference, but that was at a p-value of 0.1, so there might be a trend towards significance. At the moment, data collection is still ongoing, so we need to wait until the study is sufficiently powered. So we've got 130 participants for this study so far. So we do need to collect some more data. Also, as you can see, the sample sizes for the 4 experimental conditions are quite different. So we've got 17, 14, 17, and then 37 people in the typical lung cancer typical website condition. We hypothesize that is because the typical website condition was much shorter, so there was less dropout in that condition. So it's a study design issue. So we fixed that, and we're currently rerunning the trial. So once we finish data collection for that trial, we will know more. So what we can tell, though, is that the lowest reported intention to seek medical help was for the people who didn't receive the theory-based components, so they seem to be important. Now it might look like the personalization doesn't really play a role, but we also looked at page exits. Where do users leave our website? And so users get 3 different types of information. One is symptom information, theory-based components, and a summary for each of these, there's a personalized version and an unpersonalized version. And what we found out is that when the symptom information is not personalized, users are more likely to exit. Same for the theory-based components. When it's not personalized, users are more likely to leave our website. Interestingly, the exact opposite for the summary. So when that was personalized, people were more likely to exit. That's probably because when they receive the personalized summary, they have everything on one page, all the data they provided and our recommendations. So that's probably why they're more likely to leave at that point. So what we can conclude is that personalization seems to play a role in engagement. So to conclude, we've shown that online health information can play an important role in health education and patient decision making, and some indications that health websites can be improved by including theory-based components and information personalization. As I said, we need to collect some more data. The main route that we're doing that via is Google AdWords, as I said, but we are running into some budget constraints. So if there's anyone from Google who would like to have a chat after this, that would be all right. And that's it from my side.
Okay, we still have time for one or two questions.
I've got a question. It seems like your success factor is they went to the doctor or they want to go to the doctor. How many times do people go through and it tells them you don't need to go to the doctor?
Yeah, actually I had a look at that, and from our sample of 130 people, for 97% it was indicated that they should see a doctor. And I assume that's because people usually research online when they've had symptoms for a while. So if you've had a cough for 2 weeks, you wouldn't usually go and research that online, but if it's been around for 6 weeks, that's when you would go. So yeah, for 97% of them, it was indicated.
So a practical question.
Mm-hmm.
When you have like this agreement with doctors and start collaborating with them, how do you cope with the anonymity of the data, and because I've been having problems with that before, and I think that would be great for the community to know how did you come out to,
Oh, so for the study, the data is completely anonymous.
Yes, of course, but how did you deal with that with the hospital, for example? Because even if it's anonymous, hospitals normally don't want to share this kind of data. This is my experience.
So we're not receiving any data from hospitals. So, it's just users go online and they're basically researching their own symptoms before they've even been to the doctors, and we just go by what they tell us about themselves. So what symptoms they've had, how long they've had them, how intense. Yeah. But if it does help, before this I conducted a study where I was interviewing recently diagnosed lung cancer patients, so I did run into some of those issues. And mostly I had to go via the doctors working in those hospitals. They had to find the data for me, anonymize it before they gave it out to me. But we could talk some more about that.
Okay, let's thank our speaker and all the speakers.